So, discussing the shape of molecules, there's two ways that we can look at the shape. Way number one is to look at all the electrons. In other words, bonding and non-bonding electrons. The second way is to look at the atoms, and only the atoms. In both methods, the key is we know that electrons will repel each other, so they want to get as far away from each other as they possibly can. And the shapes that we get from electrons moving as far apart from each other as possible is called VSEPR, valence shell electron pair repulsion. What's important for you is these shapes come from the repulsion of electrons. And there's a table in the textbook that is also on your formula sheet, with the exception of the example columns are not on your formula sheet. So here we can see the table a little more clearly. This second column that says bonding groups are also called ligands, and ligands just means how many atoms are connected to the central atom. So where you see bonding groups, you want to translate that to ligands. How many atoms are connected? This third column, lone pairs, is only on the central atom. So if you can draw the Lewis structure correctly, you can use this table. You don't need to memorize it, and you will be able to figure out both the electron geometry and the molecular geometry. So for example, here is the Lewis structure of carbon dioxide. The central atom is connected by two ligands, so we have two bonding groups. Notice it's a double bond on the left, a double bond on the right, but that is not a total of 4 ligands. There's only 2 atoms, so the number of ligands is 2. Very common to look at this drawing, this Lewis structure, and say that the bonding groups is 4. The lone pairs, there are 2 lone pairs on the oxygen on the left and 2 on the right. However, the lone pairs are 0 because there's 0 lone pairs on that central carbon. So the VSEPR shape in terms of the electrons is linear, and in terms of the atom is also linear. The total of ligands plus lone pairs is the first column, the electron groups. So the next row down, 3 comes from 3 plus 0. And you have this picture. Central carbon has 1, 2, 3 ligands, even though again we have 2 single bonds and a double bond. Ligands is how many atoms, and that's a total of 3, 0 lone pairs. So the shape of this molecule in terms of the electrons are arranged in a trigonal planar arrangement, which is also the same name for the atoms. The only time that the electron geometry and the molecular geometry are different is when you have lone pairs. So the next row, 2 ligands, 1 lone pair, this would be an example Lewis structure. A ligand on the left, a ligand on the right, 1 lone pair in the central sulfur. So we end up, if you look at the atoms, it's a bent shape. In terms of the electrons are still trigonal planar. Same angles basically as the previous row. So we have linear with 2 ligands, a total of 3, either 3 ligands and 0 lone pairs, or 2 ligands and 1 lone pair, would be trigonal planar electrons. And the third choice, the highest we're going to get up to in this class, is the 4 ligands, 0 lone pairs. That's called tetrahedral. So for example, 1 carbon with 4 single bonds to 4 separate hydrogens makes up a tetrahedral shape. If you put a lone pair on it, now it's called trigonal pyramidal. And if you have 2 lone pairs, it's also bent. So there are 2 different bents. One comes from 2 ligands, 1 lone pair. The other bent comes from 2 ligands and 2 lone pairs. So being able to draw the Lewis structure correctly lets you use table 10.1 to figure out whether the molecule is polar or nonpolar. And everything comes back to a tug of war. If there is a winner and a loser, then the molecule is not symmetrical, and that means it is polar. If everything cancels, that means that there's no winner in this tug of war, then the molecule is nonpolar. There's no positive end and there's no negative end. So if we go back to these examples in table 10.1, we can figure out whether they are polar or nonpolar. So in the top one, carbon dioxide, the central carbon surrounded by 2 identical oxygens, no winner in this tug of war, that's going to be nonpolar. The second row, we look at the arrangement with 3 ligands. This would be symmetrical if we had 3 red atoms or 3 white ones, but we have 2 white and 1 red, so this is not symmetrical. There will be a winner in this tug of war, so that makes it polar. When you have the bent structure, remember we have a lone pair on there, so that also is one thing that's odd compared to the other 2, so this makes a winner and makes it polar instead of nonpolar. CH4, 4 ligands, no lone pairs, everything is symmetrical, no winner in the tug of war, so this is nonpolar. Trigonal pyramidal ammonia, 3 identical hydrogens, lone pair makes it different, so this will be polar. And the bent water, 2 hydrogen atoms rather, and then we also have 2 lone pairs on that central oxygen. So there's a winner and a loser in the tug of war. That makes the molecule polar.